Hey there, what's up? I'm Brett and welcome back to Math Hacks. Today we are finally digging into some actual algebra. Yep, the variables are coming out and we are simplifying algebraic expressions. Today we're covering all the basic exponent rules. That means we'll be multiplying and dividing with exponents, we'll be raising a power to a power, we'll be canceling, we'll even get a chance to work with negative exponents. So what do you say? Let's get started. So our first problem is multiplying 6x squared y to the fourth with 1/2 x to the fifth y. Now what I want to do here is multiply the like terms together. That means that I'm going to be multiplying the number coefficients, 6 times 1/2. I'll be multiplying the x's together, so x squared and x to the fifth, and I'll be multiplying the y's together, so y to the fourth and y. If it helps, you can go ahead and write in a little 1 here to remind you that when no power is written, it is implied that it is to the first power. Let's just go ahead and rewrite that out. We'll do a little baby step here to get us started. Okay, so I just reorganized this so we could see that we're multiplying the numbers together, the x's together, and the y's together. Again, this isn't a step you'd always have to do. You could easily skip it, but when you're beginning, it's kind of nice to just stay really organized and see exactly what you're working with. So when I multiply 6 times 1/2, I get 3. Here I have x squared times x to the fifth. Remember, our rule here is when we're multiplying, so long as our bases are the same, we add the exponents. So this is going to be x to the 2 plus 5, which is 7. And lastly here, I have y to the fourth times y to the first. Again, I have a common base of y, so I'm free to add those exponents. So I get y to the fifth power. Now notice how important these parentheses here are. This tells us that both the 2 and the y cubed are being raised to the fourth power. So I need to go ahead and put a fourth power on 2 and then apply a fourth power to y cubed. Okay, so what I did here is I added in those parentheses this time just to the y cubed because I wanted to signify that I'm going to raise a power to a power. So just kind of keep those separate for this step. You can add a set of parentheses just around the y cubed. And I made sure that I took this fourth power and applied it to 2 as well. So now I'm going to just multiply out 2 to the fourth, apply y cubed to the fourth power. Remember, our rule here is to multiply the exponents. So that's going to become y to the 12th power all over 2y to the 5th power. So here I can see, now that I've gotten rid of all the parentheses, I am free to cancel. And 16 divided by 2 is 8. And then for simplifying the y to the 12th over y to the 5th, we have 2 options. We can do the same sort of reducing, canceling technique that we did here, or we can use the rule where we subtract the powers. Either method is totally fine. It is just your preference to which you like to do. I prefer canceling, so I'm going to show you how to cancel, but you'll see it's exactly the same as if we subtracted. So I have 12 y's on the top and 5 y's on the bottom, so I can cancel 5 of these y's with 5 from the top. So on top, I'm going to be left with 7. So now I have 8y to the 7th, and I just have 1. I've canceled out everything in the bottom, so that's the answer. Now you see this was the exact same as if I would have used the rule for subtracting. In that scenario, I would have done y to the 12th minus 5 to get y to the 7th. And of course, I'd still have the 8 in front. Now, a common mistake here would be to try to start canceling things before we apply the powers. But these outside powers are going to change the numbers that we have in top and bottom. So we want to make sure that we apply the exponent first, so that way when we go and cancel out the terms that match up from top and bottom, we're not getting any errors. So I'm gonna start. Remember, this is really just x to the first power, and a power raised to another power, I multiply. So this is going to become x to the 1 times 3, so x to the third power. Next, I have y squared to the third power, so y to the 2 times 3. And lastly, z to the fourth power raised to the third power is z of 4 times 3. Now on bottom, I'm squaring it, so I have x cubed squared, which is x to the 6th, y squared squared, 2 times 2 is 4, so I get y to the 4th, and z squared squared, again 2 times 2 is 4, so I get z to the 4th. Okay, now we can do our process of either subtracting or canceling. I showed you canceling in the last one, so let's go ahead and subtract this time. When I do that, I'm going to just take the value in the numerator and subtract from it the exponent of the corresponding value in the denominator. So for the first one, I'm going to have x to the 3 minus 6, and I'll have y to the 6 minus 4, and lastly z to the 12 minus 4. Here I get x to the negative third power. Now, we haven't worked with negative exponents yet. That's perfectly legal. I'll show you what that means in 1 second. Then we have y squared and z to the 8th. All right, so in another video, I'm going to talk about negative exponents and all sort of different applications of them. But for now, all you need to know is that a negative exponent means reciprocal. So if I am working with a value that has a negative exponent and it's in the numerator, in this case, my denominator would just be 1, then I'm going to move that term with the power into the denominator to make it positive. Now, if it were in the denominator to start with, to get rid of the negative power, I would move it up into the numerator. So this one is just going to go down here. These both have positive exponents, so we're good to leave them where they are. Okay, so our final answer is y squared z to the 8th over x cubed. Our first step is to apply the power of 2 to both d squared and c cubed. Remember that our rule here is a power raised to a power is multiplication, so I'm just going to multiply these powers together. Notice I've been just copying down this term as we go along just to make sure I don't forget it. And now that we've gotten rid of the power on the outside of the parentheses, I am free to multiply these two fractions together. Remember, when we multiply fractions, we multiply straight across the numerators together and the denominators together. Now our final step here is just to combine any like variables. So I notice in the numerator I have this d cubed and d to the 4th being multiplied together. Using our rule, we know that we add the exponent, so this can be combined to d to the 7th. And on bottom, I have a c and a c to the 6th, which I can multiply together. Remember, c is really to the first power if I don't have a power written. That becomes c to the 7th. Here I'm going to use the canceling method. Again, you could also use this subtraction method that we did here. It's totally your choice. When we cancel, I see that I have 4 c's on top and 7 c's on bottom. So 4 are going to cancel out with 4 on bottom, leaving me a c cubed on bottom. And then I have 7 d's on top and 2 d's on bottom being multiplied together. So both of these are going to cancel out with 2 of these. So I'm going to be left with d to the 5th in the numerator. There you go. Now you know how to use all of those exponent rules to help you simplify algebraic expressions. If you're looking for some more difficult algebraic expressions to simplify, I recommend you click that subscribe button because I'm going to be covering some challenging algebraic expressions in an upcoming video, and you really don't want to miss that. Until next time, I'm Brett Berry, and thank you so much for watching Math Hacks.